Welcome to this week's Agronomy Update. My name is Nate Eitzmann, CCA Agronomist for Asmus Farm Supply. Over the past couple years, growers have learned a lot about herbicide resistance and what it means for their operations. Many of you have asked your local AFS agronomist about resistance and how to manage it. However, many growers are unsure how a resistant weed develops resistance mechanisms. In this week's Agronomy Update, we will go over the 4 resistance mechanisms responsible for the majority of cases of weed resistance in our region. The first mechanism of resistance is target site-based resistance. A herbicide kills a plant by binding to a specific molecule in the plant at a target site. These target sites are mostly proteins that function as enzymes. When a herbicide binds to that protein, it prevents the protein from functioning. This in turn stops an important metabolic process and the weed then dies. If there is a change in the target site, which then in turn alters the surface where the herbicide attaches, then target site-based herbicide resistance occurs. Target site-based resistance is the most common resistance mechanism and has been identified in resistant biotypes of group 1, 2, 3, 5, 9, and 14 herbicides. Examples of herbicides from these groups are Fusilade, Pursuit, Treflan, Atrazine, Roundup, and Flexstar. The next mechanism of resistance is enhanced metabolism resistance. The most common herbicide selectivity mechanism is the ability for a plant to metabolize a chemistry. This is why we can spray products like Callisto, Harness, or Atrazine on corn. The corn plant metabolizes it without harm. While the mechanics of enhanced metabolism-based herbicide resistance are poorly understood, it is widely observed that plants can learn to metabolize herbicides. The third mechanism of resistance is sequestration. Animals eliminate toxins from their body via their excretory system, such as their liver or kidneys. Plants don't have the same system as animals do, obviously, but they can store toxins in areas where they won't interfere with cell functions. Herbicides can be metabolized into less toxic forms that can be placed in the cell vacuole, or can be exported out of the cell into the cell wall. One of the most common examples of this mechanism is in horseweed or mare's tail. Glyphosate-resistant varieties of this plant rapidly send glyphosate that has entered the cell into the vacuole, thus reducing the amount of damaging herbicide entering the plant's phloem. The last mechanism of resistance is gene amplification. As we mentioned earlier in this video, a herbicide kills a plant by binding to a specific protein in the plant. This resistance occurs when the plant's DNA increasingly copies the code for a particular gene, resulting in an excess amount of proteins in the plant that the herbicide needs to bind to in order to kill the weed. For example, in resistant biotypes of Palmer amaranth, there was found to be 5 to 160 times more copies of the EPSPS gene than in susceptible biotypes. This meant that there was a sufficient amount of enzymes left untouched by the herbicide to sustain the plant growth. It's amazing how plants can mutate and adapt to herbicides. Now that you know the 4 most common resistance mechanisms, hopefully you can appreciate the importance of herbicide resistance management. If you have any questions about this week's Agronomy Update, please contact your local AFS agronomist. Thank you.